In this lesson, we will study how to simplify complex rational expressions. Now, when we say a complex rational expression, here's an example of one here. A complex rational expression is when you have a rational expression within the numerator or the denominator. In other words, said another way, you have a fraction within a fraction. You have fractions in this example within another fraction, right? You got fractions in the numerator, you got fractions in the denominator. And so what we're going to do is multiply each term within the numerator and the denominator by the LCM or the LCD, okay? I sometimes use those terms interchangeably. So this is going to be called method number one because there's going to be a couple ways to do this work. So method number one is to multiply every single term in the numerator, every single term in the denominator by the LCD or LCM, the LCD of every single fraction, every single term. So in this case, the LCD would be 24. All right, so what we're going to do is multiply by 1, but in the form of 24 over 24. We all know that any number divided by itself or any expression divided by itself is just 1. The reason why we have to do the same thing to the numerator and the denominator is so that you are really multiplying by 1. And the thing about multiplying by 1 is that the value of the original expression does not change whenever you multiply by 1. So what ends up happening is you need to multiply each term in the numerator by 24 and each term in the denominator by 24. So I wrote it like this, everybody. I put a 24 next to each of my terms. And now you're going to see me divide out the GCF, that is cross cancel. 2 goes into 24 12 times. 4 goes into 24 6 times. 6 goes into 24 4 times. And 8 goes into 24 3 times. So if I can move up here, what ends up happening is we have 12 times 1, which is 12, plus 3 times 6, which is 18, over 4 times 5, which is 20, minus 3 times 3, which is 9. So 12 plus 18, of course, is 30. 12 minus, I'm sorry, not 12, 20 minus 9 is 11. So then the simplified answer here, the simplification of this expression is simply 30/11ths. This is the final answer. So this is the method that we just used. We multiplied each term in the numerator and the denominator by the LCD of the entire complex rational expression. In the previous example, 24 was the LCD of all of the fractions. In our next example, we have 3 over x plus 1 over 2x, all of that divided by 1 over 3x minus 3 over 4x. So we're going to use this method number one here. We're going to multiply everybody by the, or not everybody, right? Every term in the numerator and denominator by the LCD. In this case, the LCD is 12x. So we're going to multiply by 1 of the form 12x over 12x. All right, so here we go. We're multiplying every single term in the numerator and denominator by the LCD. Now, x here divides out with that x there. 2x divides into 12x 6 times exactly. 3x divides into 12x exactly 4 times. And 4x will divide into 12x 3 times. So, what we're left here is 3 times 12, which is 36, plus 1 times 6, which of course is 6, over 4 times 1 minus 3 times 3. Cool. So then 36 plus 6 is 42, and 4 minus 9 is negative 5. Our final answer can be written negative 42/5. All right, everybody? Very good. All right, another example, 1 minus 1 over x divided by 1 minus 1 over x squared. Here, the LCD of all of the fractions, right, is x squared. So we're going to multiply by 1 in the form of x squared over x squared. So we're multiplying each term in the numerator by x squared. So it's really like distributing this x squared to both of the terms. Same thing in the denominator. And so you can see that x divides into x squared x times, and then x squared divides out with x squared entirely. And so what we're left with here, I'll move up on the screen for us, is x squared minus x. Let me make that a little neater there. X squared minus x divided by x squared minus 1. Awesome. Now, before we box this, we should consider simplifying this further. And we may be able to do that by factoring. In the numerator, the GCF is x. So when I factor that out, I get x times x minus 1. The denominator is a difference of two squares, so it factors as x minus 1 times x plus 1. And so the x minus 1 factors divide out, leaving you with a simplified answer of x over x plus 1. All right, good job, everybody. All right, now, example 4 here is a repeat. So it's example 1. It's the same problem. But this time, I'm going to show you a different way you could simplify this complex rational expression. Now, this second method has me adding the fractions in the numerator so that I only have one rational expression up here. So combine these fractions, and subtracting these fractions in the denominator so that you only have one fraction divided by one fraction. All right, now you and I know that in order to add or subtract fractions, you must have common denominators. So 1/2 is the same thing as 2/4. So you have 2/4 plus 3/4 in the numerator. And the LCD between 6 and 8 is 24. So 5 over 6 is 20/24. And 3/8 is 9/24. If you need some help there, remember 5 over 6. If you want to rewrite it as a fraction whose denominator is 24, you would have to multiply the numerator and the denominator by 4, would you not? So then 5/6 is equivalent to 20/4. Similarly, 3/8, if you want 3/8 to be rewritten as a fraction whose denominator is 24, you would have to multiply the numerator and the denominator by 3 in order to make that happen. So that's how I'm getting 9/24. This is just side work here, okay? All right, so then the numerator becomes 5/4, and the denominator, I think I should scroll up here, the denominator is 11/24. And what you can do now is, we already know that you divide by a fraction by keeping the first fraction the same, changing division to multiplication, and multiplying by the reciprocal of the second fraction. In an earlier lesson, I called this KCF. Keep the first fraction the same, change division to multiplication, flip the second fraction, which is the reciprocal. So now we can cross cancel here. 4 divides into 24 6 times, and then multiply straight across to get our final answer of 5 times 6, which is 30, over, really this is a 1 here. When 4 divided into 24, 4 divides into itself 1. So it's 1 times 11. So it's 30/11. Now, of course, this is the same answer that you and I got earlier, but we used a different method this time. I'm going to call this method number 2. So here's method number 2 written out in words. I add or subtract the fractions in the numerator and also in the denominator, and then KCF. Keep, change, flip. Example 5, we already did this problem, but we will use method number 2 this time around, okay? So what we need to do is we need to add these two fractions together. The only way you can do that is if you have common denominators. The LCD for just the numerator will be 2x. Down here, the only way to subtract these two fractions is if you have common denominators. The LCD for the denominator fractions will be 12x. All right, so what I finished doing here is rewriting each of these fractions up here so that they have a denominator of 2x. Notice that this first fraction did not need to change. It's just this one that needed to change. In order to have this fraction have a denominator of 2x, it needed to be multiplied by 2, of course, in the numerator and in the denominator. So when you multiply by 2 over 2, of course, you're multiplying by 1, right? You get 6 over 2x. That's how I got this fraction. The LCD for the denominator is 12x. In order to get a 12x, I need to multiply by 4 for this fraction. Of course, that means 4 over 4. 4 times 1 is 4. 4 times 3x is 12x. So that's how I got this fraction here. This fraction here is going to have to be multiplied by 3 in order to get its denominator to be 12x, which is the LCD down here. So you get 9 over 12x, which is what I have here. All right, cool. Let's go ahead and add the numerators, or the numerator fractions. So you get 7 over 2x, and that is being divided by, make that look like an x there. Okay, good. That's being divided by negative 5 over 12x. All right. So at this point, we can KCF. So we will keep the first fraction the same. We will change this to multiplication, and we will reciprocate the second fraction. So it's 12x over negative 5. All right, let's see if we can cross cancel here. Yes, 2x goes into 12x 6 times. So then what we can do is write our final answer by multiplying straight across here, which would be 7 times 6, which is 42, over negative 5. And we usually write that as negative 42 fifths, which is, of course, is the same answer that you and I got earlier. But this time around, we used method number 2. I wonder which method you prefer so far, method 1 or method 2. All right, this will wrap up the lesson, this example here. Now, again, we did this example already, but this time around, we're going to use method number 2 to get our answer. Remember, method number 2 means you want to subtract these two fractions up here, right? But you need common denominators. The common denominator for these two expressions in the numerator is just x. You're going to have to rewrite the number 1 as a fraction whose denominator is x. For the denominator here, you're going to have to subtract, and the only way you can do that is by finding the LCD for down here, which is x squared. You're going to have to rewrite the number 1 as a fraction whose denominator is x squared. All right, so the number 1, written as a fraction whose denominator is x over x, right? That's 1. This one, written as a fraction whose denominator is x squared, is x squared over x squared. Of course, this is 1. But now we can actually do the operations. So in the numerator, you would have x minus 1. That's the numerators, right? X minus 1 over x, right? You keep the common denominator of x. And all of that divided by x squared minus 1, right? That's the difference of the numerators, x squared minus 1, over x squared, the common denominator down there. And then we KCF. So we're going to keep the first fraction the same. So it's x minus 1 over x. Change this to multiplication. Reciprocate the second fraction. There. Okay, everybody? Now we can divide out common factors. So x divides into x squared, leaving you with just x left over. And then let's not forget that x squared minus 1, x squared minus 1 can be rewritten as x plus 1 times x minus 1, right, everybody? This is the factorization for x squared minus 1. So instead of writing x squared minus 1, maybe we want to write it as x plus 1 times x minus 1 so that we can see that, oh, x minus 1 divides out with x minus 1. Now be careful that you write down everything you have left over. In the numerator, you're left with x by itself, just x. And in the denominator, you're left with only x plus 1. So this is the final answer. It's the same answer that you and I got earlier, but this time we used method number 2. All right, everybody, when you're working on simplifying complex rational expressions, use method 1 or method 2. It's your preference, it's your choice, as long as, of course, you're getting the correct answer. All right. Good work, and I'll catch you in the next lesson.